Here we go again. Okay. All right, so now that's what we have here. So let's do an example. So we have this example now, okay? So we have this relation, okay? So again, a relation is just a collection of ordered pairs, right? Again, here we can draw the correspondence diagram, just like I'm doing. We have 1 to 3, that's where this arrow comes from. 2 to 4, that's where this arrow comes from. Right? 2 is assigned to 4 since we have 2, 4 in this relation. 4 to 6, as you can see. 4 goes to 6. And again, we can see the domain, right? The domain is all the x coordinates here, right? That's what the domain is. The range is all the y coordinates, as you can see. So from any relation, we can get a correspondence diagram. And yes, we can go the other way. I'm not sure if I have an example of that in today's lecture, but you can go the other way. You can really just imagine as if I gave you the correspondence diagram. You can get the domain and range, but then if I ask you, well, what's the relation? You would just basically write this set, this wonderful set that I have. Well, here's another one. Okay, this is, I know, this does not look pretty. I understand that. Here we have this relation. We have 1, 2, 1, 3, 1, 8, 5, 3, 6, 2, 6, 8. We have that. So from here, okay, from here, what I'm saying is 1 is assigned to 2. That's this first arrow. We have 1 also assigned to 3. You can hopefully see that there's another arrow here. And 1 goes to 8. So 1 is also assigned to 8. So you have 3 arrows coming out of 1. And you should be thinking in the back of your head, this is not a function. I hope you're thinking that because you're right. It's not a function. Because 1 is assigned, 1 does not have just 1 output. 1 has 3 outputs. 5, right, is assigned only to 3, so there's only 1 arrow going from 5 to 3. 6, however, has 2 outputs. 6 goes to 2, and 6 goes to 8. 6 goes to 2, and 6 goes to 8. So the domain, again, is 1, 5, and 6. All the x coordinates, again, we're not listing an element more than once. You don't do that in a set. And the range is 2, 3, and 8. Okay, so this is a fun-looking relation. Here's another one. Well, this one's not as bad. It's a little bit easier. But it's just another relation. Okay? Again, 1 goes to 2 and to 3. 5 is assigned to 3 and to 8. And 6 is also assigned to 8. That's what this is saying. And so we also have these relations. We have the domain and the range, right? The domain is all the x coordinates. The range is all the y coordinates. So for the domain, it would be 1, 5, and 6. The range would be 2, 3, and 8. Now, is there a connection with functions? I think I said already yes, and you probably should be able to see that. In fact, certain relations give us functions. It turns out that a function is a relation when no 2 distinct ordered pairs have the same first component. So a function is a kind of relation. It's a relation that has no two distinct ordered pairs with the same first component. In other words, it's a relation where if you have these two in there, then B has to equal to C. That's the only way you can have these two ordered pairs in there. Okay, that's probably confusing, I know. Another way of thinking about it is a function is a relation when, a function is a relation when all the ordered pairs have different x coordinates. That's a better way of saying it. So when all the x coordinates are different from each other. So that's another way of saying it. And also you can look at the correspondence diagram and say, oh, well, that's a function. Something on the, that's also a function. You can also say that. A relation is a function, okay, if the correspondence diagram is. That's another way of saying it. Hold on. Something here driving me nuts. Fix that wording. There we go. That's better. Sorry, that was driving me nuts. I had to fix that. Oh my goodness. But that's how you can get a function from a relation. You just basically have to make sure the ordered pairs all have different x coordinates. That's really what I'm trying to say here. Or if you draw the correspondence diagram, okay? If you draw the correspondence diagram, that would also be a function. And here's an example, right? This is a relation, but you can see that it is a function, right? You can see this is a function. Namely, we have these ordered pairs. All the x coordinates are different. All the x coordinates are different. So right away, that tells you it's a function. You could tell also from the correspondence diagram, right? From each element in the domain, there's only one arrow coming out of it. There's only one arrow coming out of it. That's all. You know, and you know, this is what the domain is. That's all the x coordinates. The range is all the y coordinates. You know, it's not like, let's go back a bit. It's not like we have something like this, right? You have two different ordered pairs, but their first coordinates, their x coordinates are different. Are the same, excuse me. It's not like that. You're not going to have a function here because you're going to have something like this. You'll have something in the correspondence diagram. You'll have two arrows coming out of the same domain element. Or in other words, you'll have an input that has different outputs, which for a function cannot happen. So this is a function. This, as you can see, is not, right? And why? Oh no, we do have a function. I'm sorry. My mistake. I was looking at the wrong thing. We do have a function here, right? You have the ordered pairs here, but all their x coordinates are different, right? This is 4, 9, and 1. They're all different. So they have the same output. That's okay. That's okay. But their inputs are different. That's really what matters most. Okay. All right, so we have that example. Let me just see something quickly. I think I have a worksheet that if you want, you could probably try it out. Well, let's do that next time. I'd rather do the worksheet next time. So let me do this. All right, let me get to the laser pointer. So we have this now. Are there any questions at all? Okay. Now, here, okay. Oh, okay. I thought we were up to the notation part, but not. All right. This is not a function then, okay? This is not a function. Sorry, I forgot I put this example in. So basically from here, we don't have a function. And why is that? Well, it's not because of this here, right? These inputs are different. These, however, are not. In other words, we have two different ordered pairs, but their x coordinates are the same. And so because of that, if you went to the correspondence diagram, as you can see, you have two arrows coming out of the same input. In other words, your input gives you more than one output. If you put 4 into this function, something's going to go wrong. It's going to give you back 7 and 2. Well, which is the output you use? It's kind of like that example I said with the square root. If you take the square root of something into the calculator, well, if it wasn't a function, you might get 2 outputs though. But which one would you use on a test? Which one would you record or whatever? That's going to be trouble. Okay. All right. Okay, let me just stop the recording a second. Let me just do this.